Hi, my name is Felicia, and today I'm going to talk to you about regular expressions. So, as you can see from that title slide, I'm the weird person in the group that suggests using regular expressions at all times. But to get to that point, it took a lot of trial and error. So today, I will tell you what not to do and what to do instead. And by the end of this, you probably won't get to that point, but you'll be on your way. So as an overview, I'll go over what a regular expression is, some example uses, how they work, why you should be using them, and I'll specifically say how regexes are used in JavaScript, and then I'll go over the don'ts and some performance tips. Okay, so what is a regular expression? In 1956, Stephen Kleen created regular expressions, and he meant it to mean that it is a regular language that can be expressed using a DFA or an NFA that converts into a DFA. More generally, like programmers and when people think of them, it's just a sequence of characters that represents a search pattern to be used on strings. And there is some debate on whether the search patterns that we use are actually can be called regular expressions or not. And so this quote by Larry Wall kind of represents what people mean by that. Because according to formal language theory, if you want to allow for all the things that regular expressions can do in most programming languages, you need to remember things. So it's no longer regular or context-free at that point. So some people just try to call them REGEXES when talking about those types of pattern matching. Okay, so some example uses are find and replace. I'm sure everyone has used that in Word or when coding. Database querying. That last line looks for a case-insensitive match of any three characters that have any three-character long string that has the characters A, B, or C. And validation. This checks for a valid IPv4 IP address, and it's quite long, but it's mostly simple. Okay, so how they work. So when you get a regular expression, like something like one of that bottom example, if you're using the Stephen Kleen idea of regular expressions, then you can use the Thompson-McNaughton-Yamato construction algorithm to turn it into an NFA or a DFA, and then you can just step through the DFA and see if the string matches. So this is a very nice site. I won't go into much detail because it's very theoretical, but they give you this example string right here, or regular expression right here, and when you click the button, it takes a while, and then you can see the NFA right here, and then the DFA on the bottom. But this is very theoretical, so that's about it. And then otherwise, in order to implement back referencing, which most programming languages have, then you have to use a recursive backtracking algorithm in order to turn a regex into something that you can use to search for strings. Okay. So why use them? Regular expressions are supported by most programming languages. They're portable. As long as you don't go too crazy, the syntax is mostly the same, going from Java to Ruby to JavaScript. They make your code shorter. So in JavaScript, when you have to if you have a slow internet connection, the size of your file matters. So if you can make your code shorter, that's nice. And they're fun. When you use them properly, you can be yes, it worked, and it's just the greatest feeling. And they can be used to match just about anything. So this is a quote from Programming Perl. If you take text in the widest possible sense, perhaps 90% of what you do is 90% text processing. So I'm not sure if I would go all the way to 90%, but text and data extraction and evaluation is very important, and reg expressions help with that. And so this is an example of how you can shorten code. So this is used in a hashing function. You partition a string into certain length chunks, and then you return an array of partitions. So the first one uses a while loop, and then gets slices of strings, and then pushes each one into an array. And the second example, just you construct a regular expression, and then you string match, and that's all you have to do. So, and like that's a very, very short regular expression. So if you have a long regular expression, it could like be represented in like 100 lines of code, like alternatively. So, okay, so now let's go into things you don't want to do. Don't try complicated validations. This is an email address validation that follows the RFC 822 specifications. It was created in Perl by concatenating other smaller regular expressions. So like someone didn't write this by hand, but still, like validation is harder than you think most of the time. Okay, so instead, break it up into smaller expressions and like evaluate them. So like in the email example, like check before the @ and then after the @, because maybe you could simplify it in that way. Use multiple regexes to filter out invalid strings at different stages, or just Google it and hope someone else did it for you. So I'm going to go over a quick example using phone numbers. So, okay, so this is a regular expression. It finds 10 digits, and there may or may not be parentheses or dashes or spaces in like the normal places. And so there's like a paragraph of text, and I just put a bunch of phone numbers, and you can see everything that got highlighted. And so you can see it working. And then, so that's step 1. And then step 2, I just found every parentheses or dash or space, and that's highlighted. And then you can just substitute a space for like nothing, and then you just pull it out, and so now you just have digits, which is nice. And now for US phone numbers, the first number in like the first 3 digits or the second 3 digits can't be 0 or 1, so that just gets rid of this first case, which is invalid. And then you, what is this? Oh yes. The second 2 digits can't be 11 in these 2 places, because like for phone calls like 911 or 411. So here I kind of found the bad ones, and then like you can just say the good ones are the ones that weren't highlighted. I'm sure there'd be a way to find the opposite, but just for simplicity, this is better. Okay, so like that wasn't that bad. It's not 6,000 characters long. And so next, don't call the constructor function, unless if you really have to. Wait, did I skip a step? One sec. I will go back to my, yes. Okay, sorry about this. I will just a little bit about regular expressions in JavaScript. So there's 2 ways to construct things. You can use the regular expression literal, which is just that, like that example. You just write the regular expression in between slashes and then add the flags after. Or you can call the constructor, where you put the regular expression in quotes and then add another argument for flags as well. And there are I, G, M, Y, and U flags, which is ignore case, global, multi-line. Y is new in ES6, it means sticky, and U is for Unicode. Okay, so now the constructor example will make sense. Okay, so the only 2 reasons to use the constructor is if it's unknown ahead of time. So like in my hash example, where I didn't know what length the partitions were going to be, then I needed to construct it using the function. Or if you're creating a regex with different flags, you can take an old regex and then just give it new flag arguments, and then so it can like match separate things. Okay, so the reason why you don't want it is because it takes in a string. So like strings already need escape characters for certain things, but regexes use escape characters for other symbols. So you'll enter \hell if you start using strings unnecessarily. And this is a quick comic. So something like this doesn't really happen in JavaScript, but in languages such as PHP, like 8 backslashes can actually happen, which is terrible to just debug and read. Okay. Okay. Don't use greedy dot star. Okay. So dot matches any single character, and star says to use to match the preceding character 0 or more times. So together they can match every string ever created. And by default, dot is greedy, so it'll match as much as possible. So like if you have a dot star and then you want to find like dot star and then like L, it'll capture everything till the end and then like backtrack. So it'll like eat up the L and then be like, oh wait, I need to look for an L, and then it has to go back one step and then find the L. So like if you're doing very complicated things, then it has to backtrack like 1,000,000 times, and that leads to catastrophic backtracking. So there's this example on Stack Overflow where someone asks why their expression was being so slow, and some people gave their solutions. And so this was this very slow one. And yeah, you can see like it's basically halted or whatever. So and if you try to sorry. Well, let me just copy this. Okay, and if you try to match it in this regex 101, catastrophic backtracking, it tells you like this is a terrible regular expression, don't do it. And so someone gave a better solution and they matched it in just 12 steps. Okay. So instead, use negated character classes. Anything inside square brackets is just like one character from these will be a match, and then the caret means everything not in that. So like not greater than sign would be a character class, and so this would be a better solution. And otherwise, if you add a question mark after star, it makes it lazy instead. Okay, so performance tips. Don't use greedy star. If you really need dot star, use question mark. Make it unambiguous. So like here, A plus A could be better written as A and then 2 or more, as opposed to like one or more A's and then another A is very strange writing. Okay, these tips are, it depends on which browser you're running in. Some browsers have like optimizations that already do these things for you in the back end, but pre-compile your regex, make your regex as detailed as possible, use anchors to show if you're searching like at the beginning of a line or an end of a line. And yeah, okay. And just basically, if you're more detailed, the regex will reject non-matches faster. So it'll spend less wasted time looking at non-matches. And so this is basically what I told you today. Just careful with dot star. Don't use the new constructor unless if you have to, and be detailed if you can. And thank you for your time.